Good evening, everyone. This is Mr. Lamb coming to you with learning target number 8, being able to prove the distance formula by way of the Pythagorean theorem. And this is what you're going to need to be able to do. I'm just going to have you come up and explain the proof to me, and you're going to have to be able to recite this proof back. So let's start with a little bit about what we know with the Pythagorean theorem. As hopefully you realize that a squared plus b squared equals c squared. And what I need to do is I need to, given a right triangle with endpoints A, B, and C, what I'm going to do is I'm going to prove the distance formula for just two arbitrary points. So I'm going to start by looking at a coordinate plane. And I'm going to pick any 2 points. I'll call them A and B. Here is point A, and here is point B. These points are very arbitrary in the fact that I don't care how far over they are, really. I will say that A is at the point x1, comma y1, and B is at the point some x2, comma y2. So they could be anywhere. That x1 and y1 could be absolutely anywhere. So I'm going to take a look at the triangle that is made when I connect those 2 points. So this distance here, this is what I'm after. I'm looking for that distance, which I call D. And what I want to do is I want to prove the distance formula, which if you go back a couple of videos, you'll know that it is the square root of quantity x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and the whole thing has to be square rooted. So in order to prove this, I'm actually going to take a look at a couple of things. The first thing I'm going to do is I'm going to turn this into a triangle. I'm going to do that. Right there. I'm going to talk about the distance it is from this now arbitrary point C. So this point C is actually located, if you think about where A is located on the x-axis some x1 units away. Well, C is at the exact same x1 value as A. They are at the same distance to the right. However, A is only up y1 coordinates, whatever that y1 is. However, B and C are at the same height, so they are both at y2. So the point C is located at x1, y2. So A is at x1, y1, B is at x2, y2, and C is at x1, y2. Well, now I want to find the distances. So I want to find the vertical distance between points C and A. This distance right here. Well, it depends how high C is. Whatever height C is, y2, and whatever height A is, y2, and whatever height A is, y1, I just subtract them to find the distance. That'll tell me the distance between C and A. Well, to find the distance between C and B, I do the same thing, but I think about the x's. B is way over there at some x2. C is at x1. So the distance between them is going to be x2 minus x1. So it's all based on these arbitrary values. Well, my triangle, as I know, is a right triangle. And I know that in a right triangle, that a squared plus b squared is equal to c squared. So in my right triangle, my hypotenuse in the right triangle is the letter D. So that is d squared. My a squared and b squared are either of the 2 legs. So I will call CB as one leg. It is x2 minus x1 squared plus the other leg, which is y2 minus y1 squared. So a squared, x2 minus x1, quantity squared, plus b squared, which is y2 minus y1, quantity squared, is equal to d squared. Well, if I want to solve this for d, and get d by itself, I get rid of a square by doing a square root. So the square root of the right side, square root of d squared is d, and the square root of the left side would be the square root of whatever all of this stuff is. It's x2 minus x1 squared plus y2 minus y1 squared. That is, by the definition, the distance between 2 points. So when we talk about the distance formula, there it is. The distance formula arises from Pythagorean theorem by finding arbitrary points A and B and finding the distance between it. I design or I draw out the right triangle. I add in a point C that has the same x value and y value as A's and B's. The other thing I could have done, right, if I would have looked up here earlier, I could have had my point A up here to point B. I could have made my triangle on the bottom. So if point A is at x1, y1, and B is at x2, y2, then point C down here, this is the same x value as B, so it's x2, and it's the same y value as A, y1. I could have done this. And if I do that, this distance is still x2 minus x1, and this distance is still y2 minus y1. So I still end up in the exact same spot, whether I make my triangle up and down, or up or down. So I could have went either way. Either way, I still end up with a triangle that has a D as the hypotenuse, and the legs will always be x2 minus x1 and y2 minus y1. And that is how you use the Pythagorean theorem to prove the distance formula.